This is Sichamba Jacob. The topic that we are looking at this evening is called Earth Geometry. You must understand that it deals with the globe. So you can see the globe that we have right over here. It has got north and south down right here. The lines which are coming from top to down, they are called longitudes. So these are longitudes like this. Or you can call them great circles. Sometimes they are also called meridians. There is one line which passes in between here. It's called Greenwich meridian, and it's 0 degrees. And the good part that you must remember is that these meridians, they help us find time or calculate time. So the other form of lines that you need to know, they are called latitudes. So if you can see nicely, the difference here is that the meridians or the longitudes were coming from top to bottom, while these latitudes, they're coming from left to right like this, you can see. And also, they are not coming at one point here. They're coming from different points. You can see this one is here, this one is here, this one is here. Latitude which cuts this in between, it passes on the center here. It's called equator, and it is 0 degrees. This is what you need to remember. So on this topic, you need to know how to find the location. It's really important to find location. So let me just show you some basics that you need to know. Let's say you've got A here, and I ask you to find the coordinates of point A. You're going to say A, this one is 43 degrees south, 15 degrees east. So this is point A. You always start with the latitude which is crossing that point, and this is a latitude that we have crossing at A, and then you say comma the longitude which is crossing that point. So the latitude here, it's 43 degrees, while the longitude, it's a 15. You can see an arrow here. It's showing that this is 15 degrees east. Let's try to find this point C. So the location of C, this is 74 degrees north, okay, 60 degrees west, okay. So you can see that for this one, where C is, the latitude here is 74 degrees north, and the longitude is 60 degrees west. So this is how you get to find the location. Again, there's something that is important. Maybe you've come across this called difference. So for difference, we'll just do an example here. So they are saying find the difference in longitude between point A and B. So you go to the diagram, point A is right here, B is right over here. So the difference between this point and this point will be denoted using theta. So we always denote difference using theta. So that will be theta is equal to, when you check here, this is 16. So we've got 16 degrees, okay? Can you see A, this A? When you check this longitude, which is cutting A, it's 16 degrees, and then we shall say plus 40 degrees, okay? And this is giving us a 56 degrees. So now, let me explain what I'm doing here. I don't want you to get confused. You can see they are saying longitude difference, meaning you go to this latitude, you can see that point A and B are falling on this latitude, and then identify the longitudes which are cutting this point and this point. So you can see that at point A, the longitude which is cutting this latitude is 16 degrees. They have given us 16. While here at B, when you check, this is 40 degrees east. Okay, don't get a 60. So you see, this is falling on the latitude. So get the longitudes which are cutting this latitude. And when you get those longitudes, you check them. Are they on the same direction? If you look at 40, it's east, while 16, it's west. It's different. If the sides are different, you add. Have you seen? I've added. Let's look at B, where we need to find the difference in longitude between D and K. So D is here, K is right here. You go to that point. You see, it's happening in 40. But the longitudes which are cutting, we've got this one. When you look at this one, they have shown us here, it's 40. And when you look at this one, it's 70. So K is 70. While D here, it's 40. And they are both east-east. So what we need to do here is to write theta is equal to 70 degrees minus 40 degrees. Why are we subtracting? Because if you look at 40 and 70, they are both east-east. So same direction, you subtract. And this will give us a 30 degrees. Let's check out number 2 here. They are saying we find a difference in latitude between A and C. So look at this. This is between A and C. If you check nicely, it's happening along this 16 degrees west. It's a longitude. So what will follow here will follow the latitudes which are cutting this. So here and here. So what latitude is this? It's 60 degrees south. So we're going to say theta is equal to 60 degrees plus 40 degrees. Now look at this. At A, it's 60, which is south. At C, it's 40, which is north. So south, north, they're different. We're supposed to add. And when we add here, the answer is coming out to be equal to 100 degrees. Okay. We do one more here, which is BM. BM, you see, this is 60 degrees south, while this is also 80 degrees south. So we're going to say theta is equal to 80 degrees minus 60 degrees. And when we subtract here, we're getting a 20 degrees. Okay? That's it. So the question that most students ask about this is that, are we supposed to put units on difference? No, there are no units for difference. Okay, let's go to the next thing here. So the next part that we're going to do here is distance. Under this topic, you are expected to calculate distance, be it in paper 1 or paper 2. So look at this example. The distance is happening along the longitude. So here they are saying calculate the distance between A and B. So between A and B, and they have specified that distance must be in kilometers. To find distance, we're going to write the formula. So master this formula. Distance between A and B is equal to theta over 360 degrees times 2 pi capital R. Okay? So that's it, capital R. Remember, I showed you now to find theta. Theta is the difference. So now we're going to find the difference between A and B. So what is the difference here? So we shall say theta is equal to 60 degrees plus 48 degrees. Because this is south, this is north. And when we do that, this is going to give us a 108 degrees. We now know that on our formula, where there is theta, we're supposed to put 1080. And then we say over 360 times 2 times the pi, they'll always give you, which is a 3.142. Okay? And then we say times the radius, they'll give you, which is a 6,370. So all these pi and r, they'll give you in the question. So when you do this, you are of course going to get a 108 times 2 times 3.142 times 6370. So when we multiply, This is giving us a 4, 3, 2, 3, 1, 4, 0.64. So we divide by 360. So when we divide by 360, this of course will give us a 12008.724 kilometers. So this is how the answer will come out. Let me just confirm. You can also confirm with me if what we've gotten here is what we are supposed to get. Okay, so this is what we need to get. So here, sometimes they may say your answer must be in nautical miles. So if it's in nautical miles, you do the same procedure. The only difference that will be there, it's here on ARA. They'll give you the value of ARA on nautical miles. So the value of ARA here on nautical miles, it will be equal to 3437 nm. Okay? So this is how the value of ARA will be. That is in nautical miles. Okay? So now, here, once you get to have that, when you've been told to find the nautical miles, the distance, do all the steps. The only difference will be right here at ARA, and also the units will change to nm. Okay? That is in paper 2. Now in paper 1, if they ask you to find distance, okay, in nautical miles, paper 1, you're going to say distance between A and B is equal to 60 theta. This is the formula you're going to use in paper 1, where this 60 degrees actually times, we'll just say 60 times, the theta will be 108. And when you multiply, that is in paper 1, when you multiply 60 times 108, this will give you a 6,480 nautical miles. So this is paper 1, where you're not allowed to use a calculator. While for this one, it's paper 2, where calculators are allowed. Okay, we now check out finding distance along the latitude. So look at the question. They're saying calculate the distance between Q and P in kilometers. So here you're going to say distance between Q and P is equal to theta over 360 degrees times 2 pi r cos alpha. So you can see that the formula I'm using here, it's almost the same as the formula for longitude. The only difference is that here there is this cos alpha. So we're going to find the theta. So when you check nicely, Q is here, P is right here. And when you look at this longitude, it's 48, while this one it's 60. So you're going to say theta is equal to 48 degrees plus 60 degrees, which will give us 108 degrees. That's our theta. So you say 108 degrees over 360 degrees times 2 times 3.142 times. The R will be 6. Since we're finding it in kilometers, it will be 6,370 times cos alpha. What are we supposed to put where alpha is? We are putting a 50 degrees. So you always put the name of the latitude where that distance is happening. What's the name of this latitude? It's a 60 degrees north. So for alpha, you put 60. If the distance was happening here, we would have put a 42. So we can say 108 times 2 times 3.142 times 6370 times cos 50. Okay, so this is giving us a 4171683.854, and then you say over 360. So when we divide by 360, this of course is giving us a 1158.01071 kilometers. Okay, so this is how the answer must be. So again, even here, if they ask you to calculate in nautical miles, you are going to just change here the value of r, okay, like it was, where it will be 3437 nautical miles, and also the units. So this is how it is. Now in paper 1, if they ask you to find distance in nautical miles, you're going to use the formula distance between Q and P is equal to 60 theta cos alpha. So the same process, but here you put cos alpha, just like that. Okay, so we go to the next stuff here. So here we are finding time. Okay, we're dealing with time. So when it comes to time under this topic, when it comes to time, you need to know the formula for time difference. So time difference. Okay, so time difference here, you calculate it like this. Time difference is equal to theta over 15. And what is this time difference? The time difference is the time, for example, if I say, what is the time here? Or how long will it take for you to reach maybe town from where you are? That's what we call time difference. And this is what we need to calculate. So now look at this question. They're saying calculate time at B. Okay, if at A, the time is 14 hours. So if the time is 14 hours here, what is the time at B? So the first thing here is to calculate time difference, which is equal to theta over 15 degrees. So here, what will be our theta? So the difference now between A and B. So you can see A is 95 degrees west, while B is 20 degrees west. Must be 95 minus 20. Remember, for difference, we said same sides, we subtract. So it will be 95 minus 20 over 15. This will give us a 75, okay? Divide by 15, and 75 divided by 15, what are we getting? We are getting a 5. So we're getting 5 hours. So now, what are we going to do with this 5 hours, the time difference? We are going to add. So it will be 14 hours, the time which is here at A, 14 hours plus 0.5 hours. This 5 hours, 0.5. So when we add here, it will give us a 19 hours. So the time at B is 19 hours. Now the question must be, how are you supposed to know when to add and when to subtract? So when you're coming from left to right, you add. So this A, where they've given us the time to be 14, is to the left-hand side, and the time that we are looking for, it's at B, which is to the right-hand side. So from left to right, you add. From right to left, you subtract. Let's check out number 2. They're saying find the time at A if at C is 17 hours. So the time at C here is 17 hours, while at A, we don't know. So we're going to say time difference is equal to theta over 15 degrees. So what is it? What is the theta here? The difference between A and C. So just get this A is 95 degrees plus here C it's 19 degrees over 15. Okay, remember when finding the difference, we said when the sides are different, this is west, this is east, you are supposed to add. And when you add 95 plus 19, it's giving you what? 114. So this is 114 over 15. And when we divide by 15, it's going to give us what? It's going to give us a 7.6. So this is 7 hours and 60 minutes, which will of course give us what? Which will give us 8 hours. So 60 minutes, it's 1 hour. So add this 1 hour to 7 hours, it will give us 8 hours. Now this 8 hours, what are we supposed to do with it? Are we supposed to add or subtract? Because we know that the time at sea is 17 hours. So we're going to say 17 hours, which is at sea, minus 08 hours. The reason why we're subtracting, because we are coming from right to left. Okay, we want to find the time at A. So when we subtract 17 minus 8, this is giving us a 09. So the time at A is 09 hours. Okay, let's check out this shortest distance. Okay, I know most people struggle with the shortest distance. So to find the shortest distance between point A and B, it should be this distance like this. Okay, so the first thing here must be to find an angle inside here. So this angle will simply be equal to 55 degrees plus 45 degrees. So when finding the angle, we always check where it's touching the longitude here. What is the name of this longitude? It's 45. Even this side, it's 55. So this longitude plus this longitude must give us the angle which is here. And this angle will be equal to 100 degrees. Okay, so I've put it here. This is 100 degrees. Okay, so now shortest distance, we use this formula. We're going to say equal to a 2, and then R, we know R is 6370, and then here we shall say cos alpha. Alpha should be the name of the latitude here, which is 60 degrees. So this is 60 degrees, and then sine theta here. Theta is an angle which is here, and that's 100 over a 2. So just work out this. This will be 26370 cos 60 degrees, and then here sine 50 degrees. So from here we can say 2 times 6370. This is giving us a 12740 times cos 60 degrees times sine 50 degrees. So this will give us the answer to be equal to 4879.7 kilometers. All right, so one more thing I would like to draw you back. I've just realized that when we are finding distance along the latitude here, I think there was a mistake here. There was a mistake here because the calculator was not in degrees. So make sure you change your calculator in degrees. So when we work out this, let me move with you from this point here because the calculator was not in degrees. 108 times 2 times 3.142 times 6370 times cos 50. So this one here, it was not okay. We're supposed to get a 277,861.8 238. So make sure your calculator is in degrees. Okay. So when we divide there, the answer is coming out to be equal to 7719.1 kilometers, like this. So let me just counter check. 108 over 360 times 2 times 3.142 times 6370 times cos 50. So this is giving us this answer right here. So that's what you're supposed to get. Okay, so let's